Yeah, so my name's Seb Jones. I'm, as Henry introduced, in the research team at Knight Frank, and kind of broadly as a team, we trouble ourselves with questions surrounding the kind of very broadly, the requirements of society and how these requirements and demands pertain to the built environment and kind of how we might need to adapt it to meet current and future requirements. So kind of whilst kind of movers being very central to my talk today, kind of really kind of from a cartographic perspective, what I want to understand is how can we kind of articulate visually the design of people moving house and really get into kind of communicating particular geographic qualities of those movers to really to kind of visually articulate particular geographic configurations kind of at the scale of Great Britain. And then finally, interrelate that with that issue of the built environment. How does particular configurations of people moving house have kind of pertinence to the form of our built environment? Just a quick technical note, all the visualizations that I've made here today are created in R using the ggplot2 library. To firstly introduce our data, we can see, so we have, or here we have the location of people that have moved house, both from, the location of from and to, and we visualize this simply using point geometries, which gives us, an impression of that spatial distribution of people that have moved house. And the first kind of point to raise is it's quite an obvious symmetry with just the general distribution of population of people in Britain. Now, this symmetry is in one sense very useful to us in that it can allow us to orientate ourselves. We can see that people's origins, the place that they've moved from, and the destinations where they've moved to, very much kind of replicate that distribution of people more broadly in Britain. We can easily identify using the data alone the locations of populated places, but also kind of more unique geographies, such as, so in the southwest of England, we can see an absence of people moving house is evidently Dartmoor National Park, and that outcrop of data points of people that have moved house is evidently Shetland, the Shetland Islands. Now, this kind of visual symmetry with population is kind of, you may agree, actually kind of some point of disinterest in this distribution, in the fact that it doesn't tell us anything particularly interesting. All we can interpret from this map of people that have moved house is it's different in different places. What we need to do is incorporate more information for this to be some kind of useful map. If we incorporate some transparency in our data points, we now get a kind of greater sense of the depth and range of frequency of movers. We can now see a greater disparity between the density of movers in more populated places relative to those lesser, more sparsely populated places in rural areas. So we might update that interpretation to, okay, movers are where people live. Again, not going to make any headlines. There are more people, if more people live there, they're more likely to move, and vice versa. So you might say from this kind of interpretation, there's nothing particularly geographically interesting there. We don't even need a map to articulate it. If we're not presenting kind of any interesting geographical kind of distribution, why are we bothering showing it? We need more information, more visual information to articulate a more interesting narrative. So we can increase that information by doubling it. We've now separated our origins on the left and our destinations on the right, our places that people have moved to, from and to. We can kind of visually emphasize the difference in these geographic qualities. So now we can say that, okay, people move from the blue dots on the left and they move to the red dots on the right. However, it's still quite redundant. All we've managed to do is kind of duplicate that lack of information and lack of anything interesting. We can now confidently say, okay, the blue dots are different from the red dots. Excellent. And also the distributions of the two look kind of very similar as well. We can't really deduce much from the difference in locations that people are moving from to the places that they're moving to. What we can kind of take away from that interpretation is, okay, we've kind of increased the amount of visual information available to us, but there's kind of insufficient visual complexity to allow us to interpret anything of particular interest. So that kind of tells us, okay, how can we incorporate more visual complexity? Now, the fact that we've got an origin and destination data set here is drawing it together with lines. Now, so my colleague astutely described this as a blue whale, which I'm sure you'll agree it's nothing like a map, but we still can't interpret any useful information. It's the kind of the volume of people that move house when we try to represent it like this visually is again still pretty useless. It's completely opaque. It's any kind of interesting patterns have been just kind of obscured into just nothing of use. So from this we can learn, okay, so we've got visual complexity, we've got more information, we need to give it more focus. And to give it more focus, we might pick out a particularly interesting geographic quality in these volume of people that have moved house. And so we're kind of where we've got this geometry of a line between an origin and destination, that kind of introduces an idea of there's variance in distance of people that move. So here we've now encoded that quality of distance. So the shortest distance moves are represented here visually with yellow, through orange of the kind of middling distance moves, and then through to kind of darker orange and pink for the long distance moves. From this, we could amend our interpretation to something like, okay, so people move short distances and they move long distances. But still, it's kind of, it might kind of look kind of cool. But again, still, what's it really telling us? How is this a kind of real accurate visual representation of that kind of the true geographic kind of distribution of people that have moved house? So one way we could try and check this is cheat with the maps and just use a histogram. So we've distributed our data here into a histogram. And so if you can very quickly observe that when we've put those into 1 mile buckets, that the vast majority of our data, the people that have moved house, kind of exists at this very short distance in a matter of a few miles. So we can update that to, okay, short and long, but mostly over a very, very short distance. So if we think back to that kind of colourful visual that I showed, we can lay out that colour ramp that I used and see, okay, if this is the distribution of frequency of movers over different distances, we should be seeing kind of a kind of proportional amount of these colours. We should be seeing a very yellow map with not a lot of orange and not a lot of pink. And as we can see, there's quite a bit of orange, and you could even say it's possibly drowned out. The yellow is possibly drowned out, which makes it possibly just very kind of mistruthful and inaccurate. The reason, well, one kind of reason for this would be something as arbitrary as the order in which we've drawn these lines, and I would imagine kind of what we're looking at here is literally something as arbitrary as the ascending order of unique ID numbers in the spreadsheet in which I uploaded it. But what we can see is kind of how much of a kind of visual impact this is having on what we're trying to interpret here. And just to kind of further emphasize this, if we put the longest distance moves at the top, we might now visually interpret here that people generally moved over a long distance, which we know to be incorrect. And to flip that back, we've now put the shortest distance moves at the top. We might now be getting somewhere a bit closer to that distribution that we saw in our histogram, that distribution of different distances of moves. However, I don't think it's still not going far enough. There's still too much visual emphasis on those middling and long distance moves. So one thing we can do to perhaps develop this a bit further is take that kind of inspiration from that histogram to, if we look individually and kind of sequentially at the breakdown of moves and play them sequentially and very quickly, we can start with those distance of 1 mile and saw that intensity of activity of people moving. And as the distance begins to increase, that intensity of color and of activity quite quickly has faded away, and only with the occasional kind of glimmer of intensity and activity and frequency as perhaps two cities are drawn together, two populated places. And so as you can see, we're kind of rolling out through the 400s of miles, and eventually this kind of just fades into just obscure blackness again, and kind of just this blackness. I know it might not be as succinct enough for something like LinkedIn, but it kind of just serves the purpose here to draw attention to the kind of the starkness and disparity using kind of our understanding and kind of perception of time and being able to compare what we saw at the beginning, all the activity, to all this black that we're seeing now, and kind of the analogy the analogy within an analogy here of the history of the Earth. If we condensed this into a 24-hour clock, that human activity only occurs in those final 2 minutes. And so why that kind of works as a device is our kind of perception of a 24-hour day is much easier than 4.5 billion years. And so here we can kind of imagine that long extent of darkness as we rolled out through the many hundreds of miles. And as we now roll back through, it's kind of beginning to enter our final 2 minutes. As that intensity of activity starts to return, we're seeing the visual emphasis of the yellows and seeing how much more data, how much kind of emphasis there is in these shorter distances. And so here, and what we've learned from this is we can combine the visual complexity that we'd used using kind of lines as geometries to get a sense of connection, along with some color and transparency to understand those variables, and then given it some focus, and that focus has been placed onto something interesting about these geographies, distance. And so just a kind of a quick recap of these bits. We've again used kind of geometry, transparency, and color to understand, okay, geometry can tell us where these things happen. Transparency has allowed us to see and get a greater perception of how many of these things these were, how many movers were there. And finally, color, used to kind of bring visual emphasis to a particularly interesting geographical quality, how far the moves were. And so now to kind of bring this into, to link this together, to draw together these kind of visual techniques that I've talked about, and kind of how it can help us understand the geographic configuration of movers, is to really link this into something to tell us something about our built environment. And so a starting point for this could be an example here being the National Charge Point Registry, which is an open government data set of charge points for electric vehicles across Britain, public ones, that is. And so I think this is kind of an interesting data set and quite a good example of the kind of challenges that we're presented with in our line of work, where it's trying to understand, okay, so what is can we look at this and kind of put it through a perspective of how are we ready to meet the kind of the rising use of electric vehicles, and how might that readiness vary across space. And so kind of in the property industry, we're thinking about, okay, how might we need to kind of address kind of a lack of readiness and adapt land or infrastructure in order to ensure that readiness for electric vehicles. And so what I'd like to do is, whilst here we're just looking at a point map of these charge points, how can we kind of reframe this understanding of a piece of infrastructure and relate it to our configuration of movers. And so one way, quite subtly, I've now related the locations of people's new houses and connected them with their nearest charge point. So quite crudely at this scale, I've just said, okay, the charge point is now connected to every nearest mover that's around it, which kind of creates puts visual emphasis on these charge points as being kind of the hubs to the spokes of movers as they're connected. And so kind of trying to understand, okay, rather than think about these charge points as individual nodes across Britain's geography, can we kind of imagine them and envisage them as these kind of centers of networks? And so kind of going back to kind of what I talked about before, with certain visual emphasis being brought to our built up areas, again, it's kind of, is it particularly insightful for us to say there are more charge points in London and Birmingham and Manchester, and therefore they are better connected? Are they better integrated? What value or what kind of insight is that really offering us? So how can we perhaps reverse, try to reverse that narrative, the emphasis of that narrative away from something such as the highly integrated areas toward those lesser integrated areas? And again, in property, we might think, okay, we need to isolate and identify these areas that are lesser integrated with our charge point network to take action. And so in order to kind of to create a visual to bring some kind of a narrative focus and also visual focus to meet that narrative, we can try to kind of just reverse that visual emphasis away from those built-up areas and toward what we might call lesser integrated locations. So here we've now changed the, or applied a color ramp. So we've depicted lesser integrated areas where we've said if there's a longer distance between a mover and its nearest connection hub, a charge point, they are lesser integrated in our charge point network. And so kind of broadly, you can see some more interesting patterns and kind of pulls our visual focus away from those bright lit up areas of kind of our big urban conurbations, and kind of completely reframed that narrative visually toward these areas, so the north, west of Scotland, the southwest, some of the east of England. Although we're still looking at something that we can recognise to be Britain, and we can still pick out places of interest that is useful to us, and just allow it to kind of much better fit and communicate the message and place kind of appropriate visual emphasis to where we want our narrative. And so that was just one demonstration of how we might visualize kind of these geographies, be they people moving house, and kind of relate them to something like our EV charge point network, and kind of broadly just to allow us to better understand and kind of communicate and visually articulate these issues. And so just to finish, kind of just to recap what I want to kind of trying to communicate here is, okay, and explore is how can we kind of modify and understand different design forms of geographies to kind of visually articulate particular geographic configurations. And then finally, how can we draw those configurations, those visual configurations, into an understanding of the kind of the form of our built environment. Thank you.
You said, always good to see different ways of handling such large data sets and what we can actually learn from them. Lots of questions for Seb, but looks like James, do you want to go first?
Thanks, sir. I mean, who are you communicating to these maps? So, you know, they look, the layered one with the Bezier curve on the rest of it, that's fantastic. Framed on a wall, so not terribly inside.
Yes, no, exactly.
That could be an audience now, right?
Yeah.
And then I was more intrigued by who the audience might be for, say, the charge point status. Yeah. There has to be a question behind it that people are trying to answer on the maps. I was intrigued by what the question is.
So I think, so firstly, on the kind of the original line map is kind of, I think that serves my point of kind of, you can't learn, the insight isn't there from something like that. It's there, kind of, I use it there as kind of a narrative device to explain that. And I think so on the final one, so we're obviously working a lot with clients who are looking to develop a particular piece of infrastructure. But I think for something obviously of that scale, that we're not learning anything. Okay, we might be able to say broadly that the kind of Outer Hebrides aren't very aren't integrated in this network, but what's it telling us on the ground? So kind of stuff at this scale, we're also kind of doing reports, and I just think trying to capture something that, if we want to make a very broad, like national level interpretation or articulation, then doing something that's just isn't going into detail on the ground. Okay, you can't pick out small patterns, but do you think it works at a national scale? So if we're publishing things in or just on the web and in reports and things.
Your time sequence line thing, it wasn't a straight line from source to destination.
No.
And it wasn't just a curved eye, it seemed to be sort of lemon shaped out there and back again. Is that just an artistic art?
No, so that's kind of,
why was it?
So that
was each one there?
So again, it's kind of, is a detail that I kind of didn't draw attention to. So when you've got the lemon shape, it's so people going one way and then people going the other way.
Yeah, that presumes that very often the house swaps effectively rather than moves.
No. So that kind of at the British scale. So we're not seeing the locations of people's houses in that. It's the geography being that could be a link between Manchester and London. So there's thousands of links going that way, and then there's thousands of links going that way. And they appear to look like the same line, but that's kind of across space.
Okay. So you simplistically,
yes.
North
No, it's a big.
You are curving that way, and southbound moves.
Yes.
Curving that
Exactly.
way.
Yes.
Well, one problem, but how did you determine how curved they were going to be? That's going to massively change the perception of how you see it and how curved these lines.
Yes. No. Of course. Yes. Just that was aesthetic. Yes. I don't know if there's a scientific way. Yes. But no, possibly. And I think again, it's kind of, if I were doing something to go into a scientific, it's not something for a scientific journal. If you're trying to very accurately represent those the magnitude of something, you might make different decisions, right?
Shouldn't have.
Over what time period were you collecting the data from?
Oh yeah, sure. So again, kind of, I wasn't being descriptive there in time period. So that was data from 2021 and 2023. Sorry, between 2021 and 2023. It wasn't something that I pulled or deemed kind of to be a point or narrative point in my presentation, so I kind of didn't put it in there. And so just in the same way that I kind of wasn't so much drawing focus to particular patterns, but yes, no, the data is late 2020 up to middle of 2023. Yes.
How much of the story in the data were you aware of before you started? And during your exploration process, did you kind of pull on any threads that went nowhere? Were there any kind of failed directions?
Yes. I'd like to say kind of over the last maybe 18 months, kind of most of the kind of the inspiration that kind of when I started looking into it was kind of, I'm sure we've all read articles of the kind of all the patterns of post-COVID, kind of are there kind of mass exoduses from like the city to I don't know, Cornwall, for example. And actually kind of when you start to look into things, there are quite kind of intricate details. These kind of interesting like narratives that you read about in any number of kind of online articles of how the patterns of people moving house has changed, might lead you to think that these things just kind of jump out at you, but they really don't. It kind of seems to be quite subtle. And I think, particularly in my head, I was like, that narrative of all the Londoners escaping to London, to Cornwall particularly, which is like, it's not really evident. And is it just kind of a bit of a people that write for the Guardian, those people? So I don't know. Yeah.
There was one last question.
The animation that you did was in terms of journey.
Yes.
But following on from your point there, did you do an animation, a chronological animation, to see whether or not people did indeed move in 2020 and back in 21?
I think that the precision of the data that we have, it only does by quarter. So I think if you had really nice, like week on week, you could get something really smooth. So all you could really do over the space of 3 years might be like, you could do it, but it would only be like 10 frames or something, or 12 frames. So I imagine you could do it, and imagine if you had some smoothness in between. I think what works with the distance is where you can have so many keyframes, it's smoother, and I think easier to detect the changing pattern. Whereas it would be really nice to do a really smooth chronological one, if there were the granularity in date. I think that's I would have done it. Had to. I thought it would look cool. Yeah.
We all go into Zoopla, one can see how much your house has gone for, but of course it also gives the date of exchange of contract. I don't know whether that data is open, but that will give you to the day when the house was sold.
I don't know if that's something that I don't know.
Land registry.
Well, we've got land registry. I think it's, then you could, yeah, thank you.